Hello student, in last video we discussed physical equilibrium. Okay, now let us discuss, we have the next topic is what? Chemical equilibrium. Okay, now if you see the chemical equilibrium is what means here. If you see, chemical equilibrium is the is the state in which, if you see here, what, in which both reactant and products are present at the concentrations which no further tendency to change with the time. Means what here? If you see, what is the meaning of the above reaction means here, I am going to take one equation, that is what, A plus, here if you see, here we have an equation, that is what, A plus B gives rise to C plus D. Okay, here small a, this small a indicate what means coefficient of A, nothing but number of moles. Here small b indicate coefficient of B, nothing but number of moles of B. Here small c indicate number of moles of C, and D indicate, here small d indicate number of moles of what? D, capital D. Okay. Now here see, chemical equilibrium occurs for the what? Reversible reaction only. Okay, very important. So here we are taking the reactions for chemical equilibrium means the reaction should be what? In the reversible. Okay. Now let us see, here we have an example. If you see here an example, we have the A plus B gives rise to C plus D. Okay, here we have one equation. So here I am taking the time equal to t equal to 0 means what? Initially. Okay, here assume that we have the 10 moles of A is there, 10 moles of B is there. Okay, here what happened? It initial. Okay, it initial what? C and D are 0. Why? Because means at the initial you are not going to get the product directly. I am talking the what? At a t equal to 0 condition. Okay, at a t means time not it started, reaction is not yet started. At that time you have the 10 moles of A is there, 10 moles of B is there. Okay, here after some time, okay, I'm taking some x time. Okay, so what happened here? So sorry, this is infinite time. Infinite time means almost here what happened? Reaction is completed. At that time, if you see here, A is 1, 0 moles, B is 1, 0 moles. Here C and D what happened? 10 moles means here indicate what? Reaction is completed. Okay, here reaction is completed. Okay, in this case reaction is what? Completed. Okay, here this is the reaction is started and here reaction is completed. But here if you see here particular time, now if you see here number of moles of A, how many we have? 2. Okay, number of moles of B, how many we have? 2. Here C, how many we have? 8. Here 8. Okay, this is called as a what? Equilibrium. Okay, here initially we don't have the equilibrium means at initial condition. At final condition also we don't have the equilibrium, but in the middle of reaction we have the equilibrium. Okay, now let us see here we have the graph. Okay, on y-axis here if you see, I took the concentration. Simply concentration we already discussed, methods of explaining concentration. Here I am taking the molarity. Okay, here I am x-axis I took the time. Okay, here if you see here on time, here if you see this reaction, what happened here? This A and B are our reactant. Okay, C and D are our product. Okay, so as the time is going on, what happened? The concentration of A and B, going to be decreases, and what happens? C and D going to be increases slowly. Okay, so these are the my what? Reactants. These are my A and reactant, and C and D are my product. Okay, so A and B concentration is going to be decreases, but C and D concentration is going to be increases. That I am going to show you with the graph. Okay, now if you see here in the case of A and B, okay, now if you see the graph tendency, what happen is slowly you can see here decrease in the concentration. Okay, on y-axis we have the concentration that is going on decreasing, means what happen? A and B are going to be consumed. Now if you see here on blue pen, you can see here this is C and D. What happened? The concentration is going to be increases. Okay, but after some time you can see here we have the straight line. Okay, here for the case of AB also we have straight line, here and C and D also we have straight line. Okay, now this dotted line indicate, okay, this dotted line indicate we have the equilibrium. Here means what? At the equilibrium you should be have both reactant and product both should be there. That condition is called as a what? Equilibrium. Okay, so if you see for this again, A and B at initial what happened? If your reaction not yet started, at that time only we have the reactant. Okay, if finally total completed means what happened? You have only product, but at the equilibrium we have the both. Okay, we have the both reactant and product, both are there. Okay, so this is about the what chemical equilibrium that we shown with the what graph. Okay, now let us see here. So again, if you go for the next here, yeah, so here this indicate means, here this condition indicate we have the what chemical equilibrium is there. Okay, so this condition, okay, this condition indicate here we have the chemical equilibrium is established. Okay, here the chemical equilibrium established. Here we don't have chemical equilibrium, here also we don't have equilibrium. And we saw the how you are going to represent with the, okay, we took the one graph, on y-axis we took the concentration, on x-axis we took the time. Okay, here this indicate means, here we have the, there is a constant line, indicate means what equilibrium is established. Okay, now go for the next one here. Okay, next slide. So now let us see the examples for the equilibrium. Okay, now let us see the examples. If you see the examples here, so here we have the examples. So if you see here, examples for dynamic equilibrium, here first we have N2 plus H2 gives rise to 2NH3. Okay, here one should you have to remember that equilibrium should you have to mention with the one double head arrow. Okay, means this one, this indicate what forward reaction, means what the N2, 1 moles of N2, 3 moles of H2 gives us 2 moles of NH3. Okay, this arrow indicate means what backward reaction. Backward reaction means what, here 2 moles of ammonia going to decompose what N2 plus 3H2. Okay, so this indicate means the reaction is what equilibrium. Next, if you see the example what we have, here we have the sulfur dioxide. Okay, sulfur dioxide and reaction with the oxygen gives rise to 2 moles of SO3. This is a forward reaction. Now what is the backward reaction? 2 moles of SO3 gives rise to what? Oxygen plus 2 moles of oxygen. This is what backward reaction. Now again, if you see the next third one, we have the H2 plus I2 gives rise to 2H8. This is a forward reaction. And backward reaction is what? 2 moles of H10 gives rise to H2 plus I2. This is what backward reaction. So as we discuss here what? So equilibrium we have to show with the double head arrow. Okay. We have the forward reaction, backward reaction. In case of what? Dynamic equilibrium means what? Our reactants are converted into products. Product has to convert into reactant. That is called what? Dynamic equilibrium. So all these are examples for what? Dynamic. Okay. Mean these are dynamic means reactants are converted into product and product are converted into what? Reactant. So these are the examples for what? Dynamic equilibrium. Okay. Now we have definition what? Equilibrium mixture means what? Okay. What is the meaning of equilibrium mixture? So a mixture of reactants and product in the equilibrium state is called equilibrium mixture. Means already we discussed just now. Okay, here if you go for the previous slide now, okay, now if you see this slide already we discussed. Now here if you see, this is the equilibrium mixture. Okay, here see if you this is the, okay, this is the equilibrium mixture. Okay, so what are present in the equilibrium? Okay, these are the equilibrium mixture, not these are the equilibrium mixture. Okay, not the initial, not the final. So what are the other equilibrium mixture? We have the both reactant and product. Okay, so I think you can come now, you can you understood very well what is the definition of equilibrium mixture. Means reactant and products both should be present at the what? Equilibrium mixture. Okay, so if only reactant is there, it is not the equilibrium mixture. If only product, no, so both should be there, then only it is called as a what? Equilibrium mixture. Okay, go for the next slide. If you go for the next slide, here we have an experiment that we have to show that we have the what dynamic nature of chemical equilibrium. Okay, so already we discussing dynamic nature means what? Reactant has to convert into product, product has to convert into reactant. Now, so dynamic nature, how you are going to confirm the dynamic nature? Okay, here we have the confirmation. Okay, we have some experiment. What is the experiment mean? Let us go for the experiment. Okay, here, okay, I'm going for this one only. So if you go for this experiment, here we have the two experiments are there. So here we have the equation, that is here if you see, okay, here another equation what we have, okay, H2 plus I2 gives rise to 2Hi, okay. Now if you see initial concentration of H2, I2, okay, here we have 1 mole of H2 is there, 1 mole of I2 is there. So I am taking the only one line. Why? Because means both the number of moles of H2, I2 same. So as the reactions proceed, what H2, I2 concentration is decreases, okay. Then if you see HI, what is the product we have? HI, okay. So HI concentration is slowly going to be increases. Here if you see here what happened, if you talk about the here, we don't have the equilibrium. Why? Because means here reactant is totally consumed. These are the what our reactants, okay. These are the reactant, this is my product. Here reactants are totally consumed. Now if you see here in the case of, now if you go for the blue line, so if you go for the blue line, what happened here? So this is my product, okay. So products concentration is slowly increasing. See after that what happened, it reached to maximum. So this line indicate means maximum. So here also we don't have the equilibrium, okay. So here where you have the equilibrium means here, here if you see at this point, okay, at this point we have the equilibrium. Why? Because means at the equilibrium we should have both reactant and product should be there. So here what happened, this constant value indicate we have the both reactant and product both we have, okay. This indicate means we have the achieved the equilibrium. Now you go for the reverse reaction. Reverse reaction is what we have, reverse reaction is what, 2 moles of HI, okay, 2 moles of HI gives rise to H2 plus I2, okay, H2 plus I2. This is a reverse reaction. So what happened now, go for that, this is my reactant, okay. Now this is the reactant means here what happened, initially now come this side, okay. Now you have to go for like this in this direction. So HI concentration is more, okay. So here initially H2I2 concentration is 0. As the time is proceeding, what happened, reactant is this one, HI concentration is going to decreases, H2I2 concentration is going to be increases. After some time what happened, equilibrium is achieved, okay. So like this you can see for the what, equilibrium with the what, concentration and time, okay. If next go for the next slide. Next we have law of mass action, okay. So let us see what is the law of mass action mean here. So what is the how can you define means, here we have two scientists, that is what, Goldberg and Weig state that the ratio of chemical reaction is directly proportional to the products of the active masses of the reactive substances, okay. What is active masses means, now you no need to think about that, later we have the concentration as a molar only, okay. Before going there, let us see the equation. What we have here, equation here, A plus B gives rise to C plus D, okay. Here small a indicate what, number of moles of A, small b indicate number of moles of B, and small c indicate number of moles of C, and small d number of moles of D, okay. Now I am going to write the rate of reaction, okay. Nothing but how much time is taking, that I am writing the rate of reaction for the forward reaction. Now forward reaction is what here, if you see this is A is converted into B means this is my forward reaction, okay. So forward reaction is what, A is converted into B, this direction taken is a forward reaction. So now if you write the rate of forward reaction, how that is what, directly proportional to A, and it has to raise to the power of what, A, okay. B, molar concentration of B, it has to raise to the power B, okay. Now if you remove the proportionality, okay, you are going to get the constant, that is what I am writing the Kf. Here F indicate what, equilibrium constant for the forward direction, okay. Now come to next, write the rate of a backward reaction, okay. That is, now backward reaction means what, now you are going to reverse means C plus D is going to convert as a what, A plus B, okay. Now in this case what, these are my reactant for the backward reaction, okay. So now, so rate of reaction always we will write with the word with respect to reactant. So now if you say here in the forward reaction what happened, A plus B is my reactant, okay. So I wrote the rate of reaction with respect to reactant. Now if you go for the backward reaction what happened, C plus D is my reactant. So here now if you write the rate of reaction, so if you write the rate of reaction what happened here, these are the my reactants. So molar concentration of C, it has to raise to the power of C, and molar concentration of D, it has to raise power of D, okay. Now if you remove the proportionality, we are going to get the one constant, that is called as a Kb. K indicate here equilibrium constant, B means indicate backward reaction, okay. Now if you go further here, what, both are attacking the rate of reaction only. Okay, rate of reaction means here so as you know very well, A equal to B. Okay, if A equal to, here if you go for the A equal to B, okay, A equal to B and A equal to again you have the C, then you can write as a what, B equal to C, as you know very well. Okay, we can write the B equal to C. So here for rate of reaction, here also we are writing rate of reaction, here also we are writing rate of reaction. So I am going to equalize now both the things. Okay, so if you go for that one, so K of forward reaction, A to the molar concentration of A, molar concentration of B equal to what, Kb, molar concentration of C, molar concentration of D. Okay, so I am going to find out Kf by Kb. Just for arrangement, I am bringing that at Kb as a what, denominator. So then what happened, this molar concentration of A become as a what, denominator. Okay, now this ratio, okay, here what, Kf by Kb means rate constant for the forward reaction, rate constant for the backward reaction. I am writing as another constant as a what, Kc. Okay, Kc called as a what, equilibrium constant. Here Kc means what, equilibrium constant, that is equal to what, here molar concentration of product to ratio of what, molar concentration of product to molar concentration of reactant. Why? Because product means here in this reaction if you see C and D, what we have, products. Okay, these are my reactant. Okay, so Kc means what, is a ratio of molar concentration of product by product of molar concentration of product of molar concentration of reactant. Okay, this is called as what, equilibrium equation. Okay, equilibrium equation means what, you have to write the Kc, then you have to go for the product of molar concentration of product and product of molar concentration of reactant. Here product, okay, means you have to go for the multiply. Okay, so Kc is called as a equilibrium constant. Here we have one important word. The equilibrium equation is also known as the law of mass action, because in the earlier days the chemistry concentration was called as a what, chemistry called as a active masses. Simply here what happened, here active mass, instead of active masses nowadays we are using the word molar concentrations. Okay, next go for the next slide. If you go for the next slide, what we have here, so this is the